Now, one of your number was very kind and said that I can actually annotate what's on the screen here to sort of show you what I would be doing if I would be playing uh, with a blackboard. And it's helpful a little bit, as I said, one of the major takeaways from this chapter is to be able to look at a picture like that shown in 1219 and be able to say, does this have main effects? Does this have interactions? And does it have perhaps no main effect? So if we're looking at, just to kind of practice with this annotation, and let me know if you don't see this, but the way that I generally tell people to do this is consider this group here. And if I squeeze these 2 points and make a dot in the middle between these 2 endpoints, that's going to be the mean for the, I believe, the older drivers. And if I do the same thing for this line here, and I squeeze these 2 endpoints and do a dot here, these 2 data points actually lie on top of each other. So in terms of the main effect for younger drivers versus older drivers, there's no main effect for the age of the drivers there. And similarly, if I take a mean here of on the cell phone and not on the cell phone, and on the cell phone and not on the cell phone, I've got, let's see if I'm saying this correctly, no main effect as well for that. So I'm sorry, I didn't do that right. I mean, this mean and this mean. So on the cell phone, younger and older gives me a dot here. Not on the phone, between here and here gives me a dot here. So there's no main effect and no main effect on either variable, but there is an interaction going on. In the same case, if we play the same game with the second one, here, I have a main effect for age here, because if I take the on the cell phone, not on the cell phone, and I consider this line and I squeeze it together and put a dot here, and if I squeeze this line together and put a dot here, I have a main effect for the younger versus older drivers. But there's no main effect for on the cell phone versus not on the cell phone. So if I consider this data point and this data point and put a dot here, and similarly for this one and put a dot here, come here, that, the mean of those 2 lines is also the same. So I have no main effect for being on the cell phone or not on the cell phone. And the same thing also happens here. There's no main effect for younger versus older drivers, but there is a main effect for cell phone, not on the cell phone. The difference in differences is the same for the 2 groups. That is, there is no interaction. Right? So, kind of playing that squeezing game for the pictures that you have going on here. Come here. I'm not sure now why. There we go. Now go to erase my little annotation thing. All right. So where we last left ourselves was this issue of the fact that you can look at more than one independent variable. And as I was saying before, this is an example of a 2 by 2 by 2 design. That is, we're going to make a little 2 by 2 cell for the light traffic group and a 2 by 2 cell for the heavy traffic group. And if you have what is called a triple interaction, that means that the difference differences across the groups varies across levels of that third variable. So in this little scenario, we have, in the issue of light traffic, we have an interaction going on between hands-free cell phone and no cell phone, such that the older drivers show a difference depending on whether they're using the cell phone or not, and the younger people seem to have about the same braking onset regardless of whether they're using the cell phone or not. However, in heavy traffic, we have a main effect for age and a main effect for a cell phone versus no cell phone. So these things help us spell out more what's going on here in terms of the external validity of our study, that not only are we interested in, do we generalize to types of people, young versus old, but also we're generalizing to different types of environments, light traffic versus heavy traffic. And she goes through exactly that picture that we had, but now in table form, where we're calculating the mean across the cells of the design for the cell phone and no cell phone groups. And it's exactly the same as we were talking about graphically in this picture here. Main effects are generally a little bit more cautiously interpreted if you have an interaction. And this is because the main effect doesn't tell you the whole story. In that, probably what you really want to do is to come back and say, well, it depends. And in this condition, you have this scenario, and in that condition, you have this other one. So this is kind of a nice little mapping that has you look at the 2x2 here and the 2x2 here in light versus heavy traffic. You can always flip the variables that are involved in a multifactorial study. In other words, you can pick what's going to be the lines and what's going to be on the x-axis. And sometimes it's just a matter of looking at your numbers and thinking about, well, what's the nicest way to communicate what we have going on here? Okay, this person coming in. And when you have a three-way design, you can ask the questions, are the two-way interactions different? And in this particular situation, this is what we have going on. There's no two-way interaction on the left-hand side and no two-way interaction on the right-hand side. That is, you have the same two-way interaction across these two groups. There is, however, a main effect for light traffic versus heavy traffic. The braking onset time is longer in heavy traffic conditions than it is in light traffic conditions. And by contrast, you could have interactions going on, but the shape of the interaction in one group is different than the shape of the interaction in another. So, in this case, we have a main effect for cell phone, a main effect for age, and a main effect for light versus heavy traffic. And down here, we have an interaction between cell phone usage and age for light traffic, and a differently shaped interaction for cell phone versus no cell phone as a function of age in the heavy traffic situation. And it can be the case that you have interactions, but the pattern of that interaction is the same across the conditions. So in this case, there is no triple interaction. You have kind of the same shape going on. Now, in the case down here, older drivers and younger drivers, that shape is the same. And she's being a little tricksy here. Downstairs, you have an interaction going on here because she flipped the older group in one group to be the younger group in the other group. So in this particular case, younger and older has been flipped in the two conditions. Yes, you have an interaction, but the pattern of the interaction is exactly opposite across light versus heavy traffic conditions. This does not happen usually in practice. And I disagree a little bit with testing all these interactions because, generally speaking, when we're doing studies, we have lots and lots of variables that are in our study. Testing all possible interactions becomes numerically a little bit hard. And the other issue going on here is when you have many variables in your study, that design becomes very unbalanced. So we can't, practically speaking, test all the possible interactions in a study where we have 15 or 16 variables going on. It is important to consider whether there might be interactions going on there. Sometimes if you've got different literatures that suggest a possible interaction, or if you're going to be doing a policy situation, you want to maybe optimize your institution's performance in education, you want to be sure that you're doing so equitably across various ethnic groups, rural versus urban, first generation versus not first generation, males versus females, fraternities and sororities versus non-fraternities and sororities. So if there's a literature out there, generally speaking, by all means, go ahead and start to take a look at it. When you're looking at the popular press, it's going to be a different set of language from when you're looking at empirical journal articles. Generally speaking, when we're looking at empirical journal articles, they will use the notation of exactly the experimental design. They will say things like, this is a 2x2 design, or they'll say this is a 2x2x2 design, and they'll tell you what the independent variables are and how many levels there are. When you're looking at a popular press article, often they'll say things like, it depends. So in words, this is what it looks like. And when you're looking at the results section, you'll hear about the various levels. So they might say things like, there's a main effect for traffic condition, there's a main effect for age, there's a main effect for handheld versus no cell phone, or hands-free versus no cell phone. And they'll say, and here are the interactions. So you'll find those explicitly referenced. When you're looking at things from articles, they'll say it depends or only when, and they'll look and they'll say how these things are different for the various groups. And that's your clue that something has gone on. Now, as we've talked about earlier in the semester, often when you're talking to journalists, A, they are not trained in statistics, and B, they're trying to communicate something quickly and in a punchy and attractive fashion for you. So they might, sometimes there's a little bit of deception going on here. And this relates to the issue of power. So in one case, a researcher might come through and say there's a main effect for sex and maybe a main effect for whether you're in a Greek or sorority condition, and there's an interaction in terms of, say, how much alcohol people drink. But at other times, and that's very clean, a person can write a nice article and say, it depends, and here's what's going on. But other times, a researcher will write an article and they'll run their big analysis and they'll run some little follow-up tests. And they might not have an interaction, but in their limitations section, they will say things like, well, when you look at just this subgroup, I don't find a difference here. What's an example of that at Mizzou? Well, many of the fraternity and sorority organizations at Mizzou that cater to minority populations are service organizations. They're out there to actually do good in the community. The participation in them by non-minority people is relatively small. And you might find that you didn't find a statistically significant difference, but that's because you're looking at a very, very small sample. Similarly, if you're looking at first generation status and community size, a lot of our first generation students come to us from rural settings. And the first generation people who we have from St. Louis and Kansas City generally are more likely to be a minority. And first generation is an interesting population to look at, and enhancing access to higher education is something we all want to do. But it's the case that if you want to break this out by community size and the urban-rural split, apart from, say, the Blue Table of Missouri, where we have a substantial population of rural and Black people, in the rest of the state, it gets to be pretty white out there. And so you might not have enough people to find a statistically significant finding. Well, as a researcher, you're kind of ethically bound to say, caution, this might be a limitation to the study, but a journalist coming back and looking at it might think, oh, well, you showed that there's no effect. They might conclude that there is an interaction when in fact there's nothing there. Right? So that wraps up for me what I had wanted to say from good old chapter 12. Are there any questions about this? And again, as I was mentioning before, the trick of this is kind of summarized in know where your main effects, know where your interactions are. And the inquisitive gives you some practice in doing some of that. And extending that to more than 2 levels is pretty straightforward, and why you might want to do it. And in terms of vocabulary, independent within groups and mixed design groups, just basically understand what's going on there. Okie doke. Well, let's come and take a look at our old friend, chapter 13. Chapter 13 is a little bit of an add-on in that we're talking about quasi-experiments and small m designs. Now, most of the studies done in the psychology department and in universities, generally speaking, are larger samples, and generally speaking, quasi-experiments are not as often done. They can be really interesting, though, and they can be a source, particularly of how psychology can start to affect policy. Quasi-experiments are a way that we observe something going on in nature that makes us kind of scratch our heads and say, gee, if it's the case that this event in nature happened, maybe there's a pre-post design, or maybe there's only a post design that will inform that. What are some examples? Well, we'll get into a few examples, but just to kind of prime the pump a little bit, if you're looking at the state of Missouri, we have had quasi-experiments data sets that involve open carry and firearms. It's, to my thinking, really regrettable that people think a good guy with a gun on campus is a good thing on the Mizzou campus. I was somewhat horrified that there was a faculty meeting about that, and this is, I think, a couple of years ago, and the people who attended were faculty saying, oh yeah, and how do I go about bringing a gun to class? It just kind of beggars belief. Missouri is also one of the few states that will not allow a registry of drug prescriptions. And the issue of addiction in the state is a terrible one. Well, if you were to enact a law, you could say, is this actually reducing deaths due to overdose? Second, and so there's ins and outs to quasi-experiments. You don't randomly assign states to the laws that they pass, obviously, but yet those laws and their effects can tell us something. Other quasi-experiments happen if you have somebody who has to come in and have a particular type of surgery, and we'll talk about that example later. Small n designs are where you're not looking at populations of people, you're looking at following maybe even just one person. And fair warning, my postdoc for 3 years at Penn State was in how to analyze data gathered from one person over the course of time. When she's going to give 4 examples of quasi-experiments, and we'll talk a little bit about internal validity issues and what makes a good quasi-experiment. So here are some examples, kind of a mix of health psychology and politics, but can we look at states' policies towards subscribing to organ donation and whether people actually donate? In Missouri, for example, I'm an organ donor. It's displayed prominently on your driver's license, and you are free to elect to sign up for it. Other states, it's the default. You will be identified as an organ donor unless you say no. Similarly, people do cosmetic surgery to feel better about themselves. As you can probably tell, I had something like that. It didn't quite take. But are there the promised effects from cosmetic surgery? In this age of the internet and public media, when you glorify or talk about an issue like suicide, is that going to have an effect on the population? That's really a very old thing. I mean, one of the things that people criticized Wolfgang Goethe was his book Sufferings of Young Werther, which inspired a lot of people to kill themselves in the Europe of the day. And as I mentioned before, if you're going to legislate on opioid abuse, is that effective? So here's some data gathered from organ donation, and we have them across various countries. Some of them allow a request an opt-in, some of them allow an opt-out. If you have to specifically consent, the rates of consenting to organ donation appear to be much smaller. Well, that's kind of an interesting thing. A subsequent slide in here talks about the fact that you may want to think about that as to whether this effect is really and truly there. So maybe there are some reasons that some countries both do not allow you to just only opt out of organ donation, and there might be other characteristics of that country that you might think, well, maybe Austria, Belgium, France, they have a very strong socialist tradition of common good. And other countries, well, the Netherlands does have socialized medicine, but maybe there's a different variable going on there that both causes people to not consent to donate to organs and also to have a law about how organ donation goes. Maybe some ethical or moral or religious reasons for not donating organs might be operant in those countries. Mm-hmm. And secondly, we might look at individuals who are in a comparison group and their self-esteem score based on whether they had surgery. And here, for example, you have self-esteem and life satisfaction and how attractive they think they are. And you're looking at individuals who underwent cosmetic surgery and people who only considered it. Well, to the extent that those people are comparable, this might be a nice study then, a quasi-experiment on the efficacy of cosmetic surgery. However, if people who are only thinking about cosmetic surgery but don't actually undergo it are systematically different than the people who are willing to do that, these groups are really not comparable. and the interactions and the main effects that you're looking at here might not actually be there. One clue in this particular figure, as you're looking at it, is at baseline on life satisfaction. It seems like there's a difference between the two groups. And on some of these other variables like self-esteem, it looks as though there's comparability at baseline. Now, what's going on here with this, the comparison group going down in self-esteem when they were higher at the beginning? Well, as we inquire about that, maybe there's some differential regression to the mean effects going on. So what we have here hinges on, if this is a good quasi-experiment, is have we designed it well? For example, if your surgery and your comparison group is a matched groups design, and they're matched on sex and, I don't know, body weight and other characteristics, you've tried to make the comparison and the surgery groups more equal. And so the counter arguments of a reasonable skeptic are not that, are not that as many as they would otherwise be. And here's another one on the effect of suicide, 13 Reasons Why. That's a little bit dated now, but it was a report of a young lady talking about her depression. And this is a quasi-experiment of something called an interrupted time series. So we have on the right-hand side, the blue line is a guess as to what suicide rates should be based on previous data going on. In other words, suicide itself is a seasonal phenomenon, and it varies by month of the year. As you can see from this, for example, suicides tend to spike during the winter months, November being, I guess, the holiday season, and suicide is a little bit lower during the summer months. And what we have here in this particular study is the orange line is going to give you the values that we observed in the years 2016, 2017, where the show is actually shown. They had a little bit of a control here in that they also looked at Instagram and Twitter and tried to assess the effect of the media on this by looking at whether people expressed that they were following the program on Instagram and Twitter. And third, here's an example of legislation and opioid use. And what we're looking at are the effects of new laws being introduced in Florida. And we're trying to consider another southern state that is in some ways similar in the state of North Carolina. And the argument from this, we introduced the new laws in Florida in the spring of 2010. If this new law is helping, then things should be decreasing. There's a big secular change, though, as you're seeing here. The North Carolina data do not increase in their opioid deaths. So, opioid deaths vary as a function of many things. The Sackler family being brought up on charges, and national changes in the opioid crisis, challenge being met at the national level will also affect the trajectory of deaths due to opioids over the course of time. However, what we're seeing in this particular little experiment is it certainly seems like Florida is decreasing ever since they passed the law, and North Carolina is holding its own. So don't believe everything you see when someone starts talking to you about how studies have shown the only way to stop a bad guy with a gun is a good guy with a gun, or even on the side of the angels, that if we would just have a drug registry to keep pill mills from happening in the state of Missouri, that this would fix our problem. So we don't have we don't have experimental control when we're looking at quasi-experiments. There could be selection effects. So as I mentioned before, maybe some countries are qualitatively different than other countries. They're bigger, they're smaller, they're richer, they're poorer. And that leads to observed differences between the groups that you have in your quasi-experiment. There can be design confounds. That is, what you think is a reasonable way to compare two groups is not. That the groups, say maybe North Carolina, varies from Florida in some other qualitative way that you didn't control for. Maybe Florida is composed of a much more elderly population than North Carolina. And what you're seeing here are differences in how the healthcare delivery systems for older people than younger people. Quasi-experiments gathered over time are also subject to maturation, that maybe people are learning, maybe people are aging out of problem behaviors going on. Well, one big issue that in my area in studying you folks is that people will often say, oh, well, you know, after you leave college, a lot of problem behaviors just go away. And other things that might be stumbling blocks to you in your life just resolve themselves. Well, when you're doing a quasi-experiment, it can be the case that maturation happens and those are the changes, and it's not due to the fact that the variable that you have assessed in time is the thing that's responsible. So for example, people will say, oh, look, after people graduate from college, their rates of alcohol use, their rates of risky and regrettable sex really decrease. Well, that's true, but there's nothing about having a degree in hand that guarantees that will happen. As you age, get older, a lot of these behaviors decline anyway. Fourth, we could have a history effect. That is, there are other things that happen out there that will change things. I know for some odd reason, I'm sleeping a lot better given the current administration than I was under the Trump administration. There's a huge history threat to prospective studies now as to maybe well-being or attitudes or how people get along socially. When you do a quasi-experiment, you have the same problems as you had in doing a regular experiment. Regression to the mean could be an issue. That, in the case of the cosmetic surgery effect, maybe those people who thought they were more attractive over time because they expected the surgery to make them look better, and other participants who reported feeling less attractive because they knew they didn't have the procedure, generally speaking, are lower. So the reason that it's lower is, maybe at baseline, one of the groups was extreme relative to its population. Attrition threats can happen. Maybe people drop out of or do not consider surgery for other reasons, and that's giving you, especially if your baseline 3 months, 6 months, and 1 year later populations are all based on people who participated, maybe those means are just due to the fact of dropout from your study. Testing and instrumentation threats are also an issue. Maybe over the course of testing, people get fatigued from filling out your study. Maybe there's ways you're answering this that is causing the apparent changes over time. And if you were doing observational studies over time, maybe what you're looking at is observer bias. Placebo effects might also play a role here, and it used to be the case, as a matter of fact, it's trotted out in your human subjects training, that sometimes medical people would put people through surgeries that were unnecessary. It was a placebo surgery condition. And, in the case of facial plastic surgery, that's not going to be the case. You know whether you look different or not, but they would actually operate for other conditions. placebo surgeries actually still kind of happen if you're doing animal work. But the moral of this slide is if you have a quasi-experiment, all of the reasons why internal validity could be a problem are still an issue for you. Now, in quasi-experiments, you don't have experimental control, and you're trying to exploit a real-world opportunity. And you just need to be careful about what variables you pick and what the limitations to that could be. There are ethical concerns, as I mentioned, the surgery issue being you don't want to put people through things, unnecessary suffering. And you need to think about whether what you're looking at contains external validity. So this is a big issue for any psychological research done in the past year. It has a big asterisk by it of this study was done during the time of COVID and all of the stresses that accompanied people's lives at that point. So, I mean, if you're doing a study, you just need to balance what you can do with the data that you have available and how well it's going to address the issue that you're managing the trade-off between a real-world opportunity and the opportunity to actually collect some data that would be generating some useful conclusions for you as a psychologist. This is a little bit of a vocabulary thing. In some ways, quasi-experiments and correlational studies are kind of the same. Maybe they're independent groups. Neither of them use random assignment, and neither manipulate the variables. So the way the author is making this distinction is in correlational studies, you're going to grab a sample of convenience largely, and there's nothing going on in the world out there that says, hey, this is an opportunity to watch what's going on. In quasi-experiments, you are generally keying this to some event or some characteristic over the course of time. So studies with participant variables in a correlational study are designed to document similarities and differences associated with those characteristics. It's not to generate an entirely new theory based on that. So, I mean, it's kind of a matter of distinction of, are you trying to say this presents us with a unique opportunity to look at things? I'd like to open up a little bit of a box to think about smaller n and designs. Here's a picture that's due to a person named Raymond Cattell, who was a person who looked at intellectual abilities and personality. And he came up with this original idea around World War II, and it still kind of carries with us today as a useful way to think about the kinds of research you might do. The reason that I'm bringing this up is the second part of this chapter talks about small n and single subject designs. And very frequently, when you're talking with someone who has an acquaintance with psychology, they think, oh, well, psychology has now progressed to the point where we no longer do single subject designs. And my point in departing a little from the book here is my argument is that looking at smaller subject designs can be very useful if you're doing things that are interventions that are targeted at the individual level. For example, if some of you have diabetes and you're looking at insulin, there are various insulin delivery systems for you that are treatment options. Diabetes happens, how you regulate blood sugar in a person varies over the course of time, though. And how it varies over the course of time is different for different people. It's different for younger people than older people, for heavier people than not so heavy people. And this data box is a way that we can think about our data. So what we have here are three dimensions. You could have one or more variables in your study. You could have one or more people in your study. And you could look at one or more measurement occasions. And almost all of the work that you are looking at in this book has been what Cattell would call R technique. That is, we're looking at a whole bunch of people on one measurement occasion across many variables. If we're doing a two-variable study, we might just have two variables. But that's a slice of the data. When you're looking at RStudio Cloud, remember we were thinking of our data as having people in the rows and our variables in the columns. Now that's the point of what I want to say is that's not the only way that you can look at data and think about and test hypotheses. Another thing you can do is you can take just one person across many variables, but measure them over many, many times. And that is also going to give you a set of relationships between those variables for that one person. And the other advantage of that is you can look over the course of time to see what's going on, because maybe what's going on at one measurement occasion starts to affect what goes on at some other measurement occasion. What can I think of for an example here? Well, one thing is when you go to the doctor in the before times and the doctor takes your blood pressure, sometimes there's what's called the white lab coat phenomenon, that the doctor takes your blood pressure and they say, oh, that reads a bit high. You know what? I need to go and see another patient right now. Would you mind waiting here or waiting in the waiting room for a little bit, and I'll come back and we'll continue this. And the reason that the doctor is doing that is that she thinks that there's something going on with your blood pressure that is a momentary fluctuation. And hopefully you'll have time to calm down a little bit. And when she comes back in, takes your blood pressure again, you'll be back at baseline. That works really well for you young people because your blood pressure can change over the course of 30 minutes quite dramatically. But you know who that doesn't work well for? Older people. That if you've got John or Mary coming into the lab or the office and they're taking a blood pressure and it's high, an hour later it's still going to be high. This has to do with how the circulatory system, the autonomic nervous system of older people works differently than younger people. And when I was at Penn State, we were looking at a study of the advanced elderly, that is, women, because only women live that long, generally speaking, and very few men, but 85 and up. And if they have a high blood pressure reading, basically you're going to have to wait 3 days before you get a good baseline. That story, that finding is not possible for you to find out just looking at lots of people at one measurement occasion. You would really need to have data gathered across measurement occasions on perhaps a single or a small number of people. There's a third option here. I see I'm getting out to time, so I will talk about that. It's also possible for us to take one variable, say this one here, across lots of people, across many measurement occasions. That's called a T-technique study. And generally speaking, when we're looking at how one variable is changing across lots of people, across many measurement occasions, you're looking at a learning study. And that's an entirely, to me, interesting way of thinking about all of the possible data you could collect. The conclusions from R and P and T technique studies are all different. And the threats to validity for these three are also all different. But I shan't, in the context of this class, get really into that in depth, but it is useful to put the marker down that when you're looking at data, there's various ways to slice up that cube. So to return to her discussion of this, in large N designs, we have lots and lots of people, and we're going to combine all of the data from each people into each group and look at group averages. Large samples are going to give us a lot of precision. And you can use these studies in both basic and applied research. In small N designs, you're looking at one person. And almost always, as in the data box, you're looking at a repeated measures design. You're testing this single person or small group of people across multiple measurement occasions. I disagree with her. Sometimes if you have a small N design, you do summarize them a bit, but you often can talk about each individual. And if you have a design where you're looking at how a person is functioning during treatment, you can look at those periods when they have treatment and those periods when they don't have treatment. So therapy or medication. In the course of these studies, you can look at, are they more symptomatic when they don't have the medication than when they do? And the reason that we get into that is, well, maybe people have spontaneously recovered, or they have matured out of the behavior that you're interested in looking at. I see we're going to have to put a pin in it for there. I will take this up, and from here we're going to go into examples of small N designs.